Look closely at the undergrowth, at the fur of a sleeping animal. You might just spot a tiny dark speck, barely noticeable to the naked eye. This, my friends, is a flea. Don't be fooled by its diminutive size, for this creature possesses an extraordinary ability. It can jump over 350 times its own height. Imagine a human leaping over the Eiffel Tower in a single bound. This is the incredible feat that the flea accomplishes with every jump. Fleas are more than just a nuisance. They are marvels of nature, tiny acrobats with a story to tell. Their jumps are not mere acts of locomotion, but feats of engineering, powered by a fascinating combination of muscle, protein, and evolutionary ingenuity. Join me as we delve into the world of these miniature daredevils and unravel the secrets behind their astonishing leaps. The flea's legs are a marvel of natural engineering. Each leg is equipped with powerful muscles and a unique protein called resilin, which acts like a spring, storing and releasing energy with incredible efficiency. Resilin is one of the most elastic substances known to science, allowing the flea to catapult itself into the air with remarkable speed and force. When a flea jumps, it releases the stored energy in its legs almost instantaneously, propelling it to heights and distances that are truly astounding for such a small creature. But the flea's story doesn't end with its jumping prowess. These tiny insects have evolved to be incredibly resilient and adaptable, thriving in a variety of environments and on numerous host animals. Fleas have been around for millions of years, and their ability to survive and reproduce in diverse conditions is a testament to their evolutionary success. The flea's life cycle is another fascinating aspect of its biology. From egg to larva to pupa to adult, each stage is uniquely adapted to ensure the flea's survival and proliferation. Flea eggs are laid on the host animal, but they often fall off into the environment, where they hatch into larvae. These larvae feed on organic debris until they pupate, eventually emerging as adult fleas ready to continue the cycle. Despite their small size, fleas have a significant impact on their ecosystems and the animals they infest. They are both a marvel of nature and a reminder of the intricate web of life that connects all living things. So next time you see a tiny speck on your pet or in the wild, take a moment to appreciate the incredible journey and the remarkable abilities of the mighty flea. To fully appreciate the magnitude of a flea's jump, let's consider the numbers. Fleas are tiny insects, often overlooked due to their minuscule size. However, their jumping ability is nothing short of extraordinary. These minuscule creatures, measuring a mere 2 to 3 millimeters in length, possess a jumping prowess that is unparalleled in the animal kingdom. Despite their small size, they can achieve feats that would be impossible for much larger animals. Fleas can launch themselves a staggering 20 centimeters horizontally and 18 centimeters vertically. To put this into perspective, this is equivalent to a human being able to jump over a 2-story building or leap across a swimming pool in a single bound. That's like a human leaping the length of a bus. Imagine the sheer force and energy required to achieve such a feat. It's a testament to the incredible design and efficiency of these tiny creatures. Their jumps are lightning fast, clocking in at an acceleration of 100 times the force of gravity. This means that in the brief moment of their jump, they experience forces that are far greater than what astronauts feel during a rocket launch. This incredible acceleration is achieved in a fraction of a second, demonstrating the sheer power packed into their tiny bodies. The speed and precision of their jumps are a marvel of natural engineering. But how do they do it? What mechanisms allow these tiny insects to perform such extraordinary jumps? The answer lies in their unique anatomy and the specialized structures that have evolved to maximize their jumping ability. How can such a small creature generate so much power? The secret is in their legs, which contain a highly elastic protein called resilin. This protein acts like a spring, storing energy when the flea prepares to jump and releasing it explosively to propel the flea into the air. The answer lies in the fascinating mechanics of their jump, a carefully orchestrated interplay of muscles, energy storage and release. When a flea prepares to jump, it contracts its powerful leg muscles, compressing the resilin and storing potential energy. This is no ordinary jump, it's a precisely calculated launch, a testament to the power of evolution and the remarkable efficiency of nature's design. The flea's jump is a perfect example of how even the smallest creatures can possess extraordinary abilities, showcasing the wonders of the natural world. Don't let their size fool you. Fleas are equipped with a powerful set of legs, specifically designed for jumping. These tiny insects, often considered pests, have evolved an extraordinary mechanism that allows them to leap great distances relative to their size. Fleas can jump up to 200 times their body length, which is equivalent to a human jumping over a 60-story building. This remarkable ability is due to the unique structure and function of their hind legs. Their hind legs are significantly longer than their other legs and contain massive muscles that contract with incredible force. These muscles are not just any ordinary muscles, they are specialized to perform one of the most powerful movements in the animal kingdom. The hind legs act as a lever, amplifying the force generated by the muscles. This lever mechanism is crucial for the flea's jumping prowess. These muscles are connected to a highly elastic protein called resilin, which acts like a spring, storing energy before releasing it in one explosive burst. Resilin is one of the most efficient elastic proteins known, capable of storing and releasing energy with minimal loss. When the flea prepares to jump, the muscles contract and compress the resilin, much like compressing a spring. This stored energy is then released rapidly, propelling the flea into the air. Imagine a catapult drawing back slowly, building tension before launching its projectile with immense force. The flea's jumping mechanism works on a similar principle. The gradual buildup of tension in the muscles and resilin is akin to the winding of a catapult. Once the tension reaches its peak, it is released in a split second, resulting in a powerful jump. This is a crude analogy, but it illustrates the principle behind a flea's jump. The efficiency and speed of this mechanism are what make fleas such formidable jumpers. In fact, the acceleration they experience during a jump is among the highest recorded in the animal kingdom. This allows them to escape predators and move quickly between hosts. The muscles contract, storing energy in the resilin, which then releases that energy with remarkable speed and efficiency, propelling the flea into the air with incredible force. This entire process happens in the blink of an eye, showcasing the incredible design and efficiency of nature's mechanisms. Fleas may be small, but their jumping ability is a testament to the wonders of biological engineering. The star of the show, the secret weapon behind the flea's extraordinary jumping ability, is a remarkable protein called resilin. This rubber-like protein is incredibly elastic, far more so than any man-made rubber. It acts like a biological spring, capable of storing vast amounts of energy and releasing it with minimal energy loss. When the flea's leg muscles contract, they compress the resilin, storing energy like a wound-up spring. When the flea is ready to jump, the resilin is released, catapulting the insect into the air with incredible speed and acceleration. This efficient energy storage and release system is what allows fleas to achieve their remarkable jumps, defying gravity with each leap. In the wild, size often dictates survival. Small creatures like fleas are constantly under threat from predators, from spiders to birds to larger insects. For the flea, its powerful jump is its lifeline, a crucial adaptation that allows it to escape danger in the blink of an eye. Imagine a bird swooping down, its beak aimed at a flea feasting on a rodent's fur. Suddenly the flea leaps, disappearing in a blur, leaving the bird grasping at thin air. This is the power of the flea's jump, a split-second maneuver that can mean the difference between life and death.